Recording.
There is nothing below screen. I don't see anything. I am seeing show screen. Show screen. Stop showing. Give keyboard.
Good morning, members. A very warm welcome from Team Training and Education to all the members. Today, we are conducting our 55th webinar in Gyan Ganga webinar series. Today's our topic is analysis of engine damages. And today we have our new faculty for this webinar series, Mr. Harimon Walia. Though he is new for this webinar series, he is working for ISLA since its inception. Mr. Harimon Walia is a surveyor from Faridabad. He has also circulated bi-monthly bulletin, the surveyor training from 2000 to 2002. His article on a systematic study of road accidents was published in IIDA Journal of September 2003 issue. Was faculty member for training campus organized by ISA prior to this ISLA since September 2002 to 2003 at various places like Puri, Siliguri, Varanasi, Gorakhpur, Gaya, Gorakhpur. He is also faculty for various training campus organized by ISLA from 2010 onwards at various places like Kanpur, Varanasi, Nagpur, Allahabad, Mathura, Ghaziabad. He is a B Mechanical and fellow member of Indian Institute of Insurance Surveyor and Loss Assessor. He has a practical experience as he was working as a works manager in leading automobile authorized dealer in Patna and Jamshedpur, and is an independent surveyor since 1972 with Motor Marine Engineering Department. Now I request Mr. Harimon Walia sir to start with today's session. A very warm welcome to Mr. Walia sir and to all the members. Over to Mr. Harimon Walia sir.
Thank you, Mr. Sachin. Very good morning to the organizers of webinar and my dear surveyor friends. Under Gyan Ganga 55, today's topic is analysis of engine damages for motor OD claims. My index shows definitions, anatomy of an IC engine, cause of engine damages, and case studies. Under definitions, I will explain negligence, gross negligence by accidental external means, consequential loss, proximate cause, hydrostatic lock, engine seizure, water wading depth, and firing order. Negligence, it is the lack of attention to what ought to be done. Failure to take proper or necessary care of a thing or person in time. Lack of necessary or reasonable care in doing something. Carelessness, unintentional act of careless omission. Negligence is covered by motor insurance policy. Gross negligence or willful neglect. It is the intentional neglect, fully knowing the consequences, resulting in loss aggravation, extension of loss. That means enhancing the loss after the accident. Gross negligence is not covered by the insurance policy. Please note, after the accident, loss aggravation due to adverse circumstances beyond driver's normal control may not be treated as gross negligence, provided it is properly explained by surveyor based on sound reasoning to convince the insurers. I will give the case studies later on this point. Accidental external means it has following two factors. One, accidental is a sudden unforeseen occurrence as one factor. External is outside of the vehicle. with these components, cargo, occupants, driver being one unit as the second factor. Means stand for through or dwara in Hindi. By accidental external means includes two factors, accidental and external, to be simultaneous to cover loss or damage to a vehicle under Section 1 of Motor Insurance Policy. Please note, as damages due to self-ignition have no external factor, therefore this peril is mentioned separately with fire. Consequential loss. The consequential loss in motor insurance policy means the direct financial losses suffered by the insured consequent to the accident of his vehicle. The examples of consequential loss are financial loss of business, wages, or any other loss to the insured due to the accident, but other than own damages to his vehicle. It is not the resultant or extension of damages sustained by the vehicle after the accident. Sometimes aggravation or extension of loss to a damaged vehicle after the accident is loosely called as consequential loss. This is wrong. The consequential loss is not covered by motor insurance policy as per general exceptions applicable to all sections of motor policy. Proximate cause. It is defined as the active, efficient, and the nearest cause immediately before the loss or damage that sets in motion a train of events which brings about a result, meaning loss damage, without the intervention of any force started and working actively. For the coverage under the motor policy, the proximate cause of loss or damage should be an insured event or a peril and also justify accidental external means factor. Hydrostatic lock. When incompressible liquid, maybe engine oil, water, petrol, diesel, whatever, locked inside the combustion chamber of an engine, opposes upward displacement of piston or locks it during compression stroke. It is called hydrostatic lock. Engine seizure. When an engine is overheated due to lack of lubrication, that is engine oil, or short of cooling water, that is radiator water. Engine parts like piston, rings, crankshaft, bearings, cylinders or liners are overheated, melted together or seized. Please note, after engine seizure or hydrostatic lock, crankshaft will stop turning. If any external force is applied to start engine, it will aggravate the damages. Water wading depth. Wading means driving through waterlogged areas. It is important to check your vehicle's maximum water wading depth for speed under 7 km/h as specified by manufacturers. As an example, Ford company specifies maximum water wading depth of 550 mm for EcoSport model and 800 mm for Endeavour model. Tata Nixon maximum water wading depth is 300 mm and that of Land Rover Discovery is 900 mm. Higher the height of air suction point, better is the water wading capability of a car. If the water level outside the car is higher than the specified water wading depth, water can be sucked into the engine through air intake pipe of the air cleaner, enter the combustion chamber of the car engine, and damage engine parts due to hydrostatic lock. Remember to keep moving all times at low speed, high RPM, and not to idle midstream. Otherwise, water sucked by exhaust pipe would block the exit of exhaust gases and stop the engine. If the engine stops midstream, do not try to restart it at that spot to avoid serious damages to the engine. Here is the illustration of water wading Here the car is entering into the water. This is mid and the last position. You see the air intake point here and the bow wave. A bow wave travels ahead of the car when the car is moving. When you always see when going through water, there is a bow wave going ahead of your car. For safe water wading, keep a steady speed of 7 km/h. Do not cross the bow wave and keep water level below air intake point of the vehicle. This is the air intake. Keep water below. Water wading consequences. When car is water wading, very small quantity of water may continue entering the engine cylinders, one after the other during the intake stroke. As long as external water volume in any cylinder is less than the clearance volume, there is no problem except it may cause engine missing. The moment external water exceeds the clearance volume in any one cylinder, engine would stall or its internal parts be damaged. Firing order of an IC engine. The order in which the ignition takes place in various cylinders of a multi-cylinder engine is called firing order. Every engine cylinder must fire once in every thermodynamic cycle. In a spark ignition engine, that is gasoline or petrol, the firing order corresponds to the order in which the spark plugs are operated. In a diesel engine, the firing order corresponds to the order in which fuel is injected into each cylinder. Following factors must be considered before deciding the firing order in IC engine. Design of crankshaft, number of cylinders, that is 1, 2, 3 up to 12. Arrangement of cylinder, that is inline, also called straight, and V engine like V6, V8, V10. Examples. Inline, for 3-cylinder engine, 132 or 123 is the firing order. Inline 4-cylinder engine 1342 is the firing order. Inline 5-cylinder it is 12453. Inline 6-cylinder engine it is 153624 is the firing order. V6 engine R1, L2, R2, L3, L1, R3 is the firing order. R and L means right and left as seen from the front side of the engine. Anatomy of an IC engine. IC means internal combustion engine. Here is the section view of 4-cylinder IC engine starting from the top. It is tappet cover. Then you see the overhead camshaft here, the valves here, the piston is here, the ring gear is here, then the flywheel is here. You can see the connecting rod here. Then you can see the crankshaft here, and then the sump at the bottom. Then there is camshaft drive belt and the engine pulley. These are the main parts. View of the dismantled engine parts. Again, you see the dismantled parts, tappet cover, sump, injectors, and the engine block, crankshaft, piston and connecting rod, cylinder head, glow plugs, and many other parts. Crankshaft and connecting rods of 6-cylinder engine. Here you see the 6 connecting rods, and here is the crankshaft. Now the connecting rod, this is the upper side, is the small end of the connecting rod. The lower side is the big end of the connecting. Then in the crankshaft, you will see this projecting parts are the big end journals. The big end journals, here the big end of the connecting rod is fitted to the big end journals. These are in the central position, you see the main journals which take the load of the crankshaft. This is how the construction of the crankshaft is there. Following are the major parts of an engine. Tappet cover, starting from the top position, you will see, here I have shown you the tappet cover, cylinder head, and camshaft. Now you see SOCH, SOHC, or DOHC. This means single overhead camshaft or double overhead camshaft. Here, camshaft is fitted over the cylinder head. Then there are other parts housing inside the cylinder head. That's inlet valve, exhaust valve, then inlet manifold, exhaust manifold. The third major part is engine block, also called crankcase. Crankshaft is another major part. Again, I have mentioned here camshaft because in earlier design, the camshaft was cam in block position. Now it has gone to the cylinder head overhead. So there is a change in design from earlier to the latest. Then crank, again, the engine block also contains piston, pin, rings, liners or cylinders, connecting rod plus main bearing and big end bearings. Radiator and intercooler are the cooling devices. Sump or oil chamber and oil pump at the bottom side. There are parts like injectors, also called atomizers, glow plugs in the diesel engine, fuel injection pump called FIP, turbocharger, supercharger. There is difference between the two. I will explain later on. Spark plug, petrol engine, AC compressor, vibration damper, crank pulley, alternator, self starter, air cleaner, water pump, fan blade and air compressors are fitted to the outer side of the engine. Piston design of an IC engine. Pistons are cast from aluminum alloys. Piston head, you see the piston head or crown is the top position surface against which the combustion gases exert pressure. Piston rings are for gas sealing. These are the piston. Gyan pin or piston pin of hardened steel are fixed in the piston. Skirt is an important part. You see the skirt here. That part of the piston located between the first ring groove above the pinhole and the bottom open end. This is called skirt. Major thrust face of skirt. This skirt portion carries the greatest thrust load. It is on the right side of the piston when viewing the engine from the front end with the crankshaft rotating clockwise. This is the clockwise rotation. Then this is the right side of the skirt, and this is the major thrust face. Here, every pressure is exerted on this face. Lubrication system of IC engine. Here you see the lubrication, the sump with full of engine oil, and then it under pressure it circulates. This is the pump which circulates under pressure. This is the lubricating oil, and starting from here it goes to the oil filter, then goes to the crankshaft, and from here it goes to the camshaft. From there it goes to the rocker shaft, and then it comes back. And there is a oil filling from crankshaft. Please understand oil filling from crankshaft. This crankshaft have got these webs, and they strike this oil and fling the oil here on the under the piston, and this lubricates the cylinder and piston walls. And then it, after throwing here, the excess oil is cleaned by the oil ring, and then the rest comes back here in the sump, and this is how it keeps on circulating at a particular temperature and pressure. Lubrication system of IC engine. The engine oil is sucked out from the sump by oil pump, then forced through the oil filter and pressure fed to the main bearings. From there, oil passes through feed holes into the drill passages in crankshaft and onto the big end bearings of the connecting rod. The cylinder walls and piston pin bearings are lubricated by oil filling dispersed by the rotating crankshaft, the excess being scraped off by the lower oil control ring in the piston. An oil tributary from the main supply passage feeds each camshaft bearing. The excess oil then drains back to the sump where the heat is dispersed to the surrounding air. See the temperature of petrol engine parts. Here is, you see, here is the piston, this is the cylinder, and then intake manifold has got 60 degrees centigrade. Here is the intake from which sucks air from here. Then intake valve is here at 250 degrees Celsius. Then spark plug is at 600. Celsius cylinder walls are kept at 185 degrees Celsius, and the piston skirt, this is the piston skirt. This is maintained at 190 degrees centigrade, lubricating oil at 70 degree, and the coolant, this is around this cylinder. This maintained at 150 degrees Celsius. Exhaust valve. This is the exhaust valve which attains the temperature of 650, and the exhaust flow is at 450 degrees centigrade. This is the working of petrol engine. You see here, this crankshaft is rotating in a clockwise direction. When seen from the front, it is rotating in the clockwise. Then you see there is ambient air being sucked here during the intake stroke. Then starts the compression stroke here, and the firing takes place. Just see the firing from the spark plug. Then the power stroke is coming, and lastly the exhaust stroke for the exit of the exhaust gases. This is how the engine is working, and there are the 4 strokes. Spark plug releases a spark in the combustion chamber just before the end of compression stroke at a voltage of 12,000 to 25,000. Again, please note that thermodynamic cycle, that means Otto cycle for petrol engine or diesel cycle for diesel engine, is completed in 2 revolutions of crankshaft, that is in 720 degree rotation. 1 thermodynamic cycle is completed, or the 4 strokes are completed. This is the diesel engine. The working is the same. The difference is that there is no spark plug. The fuel injector is there, and during the compression stroke, the fuel is injected. In diesel engine, due to high compression ratio, lot of heat is generated in the combustion chamber during compression stroke, and ignition of air fuel mixture is induced by heat of compression. This compression has got very high heat, and that ignites the air fuel mixture. Diesel is injected just before or after TDC position of piston in compression stroke as per engine design and desired performance from the diesel engine, because this is adjustable. Cause of engine damages. Cause of engine damages can be oil starvation, cooling water starvation, external water damages, hydrostatic lock, accidental impact, fire, and mechanical failure. Now starting from the oil starvation, just a minute. Only once any mechanical system becomes depleted of lubricant, the lubricant film is no longer present to support or protect the moving surfaces. Then direct surface to surface contact will occur, and excessive heat would be generated to damage the rotating and sliding parts of an engine. This is called oil starvation damage. Piston after lubrication failure. This is the piston, and this is the thrust phase of the piston. Figure shows scuffing marks on the major thrust side of piston skirt as the lubrication film failed due to oil starvation. When seen from front side, a standard engine rotates in clockwise direction, and the piston marks will be found on the right side, called the thrust side. Please note that the engine lubrication system is designed to deliver clean oil at the correct temperature and pressure to every part of engine, and perform the function of minimizing friction between the bearing surfaces of moving parts by dissipating heat. Oil starvation damage admissibility. Oil starvation losses lead to overheating, and finally the seizure of engine due to various reasons. Therefore, check following parameters for admissibility of an oil starvation claim. Cause of accident should be convincing, concurring with the damages detected, and the proximate cause is covered by the policy. Damages are not due to mechanical failures like sump or head gasket, oil filter body leakage, defective oil pump, or improper insufficient oil. There should be no gross negligence by the driver. The damages are due to accidental external means. Let us study the following examples. One case study: a vehicle is driven in normal course with leaking sump or oil filter assembly or head gasket or improper insufficient oil in the sump, causing damages to engine parts due to oil starvation leading to engine seizure. Are the damages payable? As damages are due to mechanical defect or bad maintenance and not by external accidental means, the claim is not payable. Please note the time taken for engine to seize depends on vehicle speed, vehicle drag, air drag, road surface condition, road gradient, ambient temperature, motor oil quality, quantity, leakage rate, and engine design. So many factors decide the time taken for engine to seize. Case study. It is reported that after accident, a vehicle settles in upside down or overturned position, but engine keeps idling for some time, thus leading to seizure due to oil starvation of pressure-fed parts like main and big end bearing, etc., as oil pump will be inoperative in that condition. The damages to engine are payable or not. Normally, the engine will stop idling within a short time due to air bubbles in fuel pipes, especially in diesel engine, or due to load on engine, as normally the vehicle is in gear. But there could be other reasons for idling. A thorough investigation into the cause of damages should be made to know the real cause of damages. If the driver is safe and sound after the accident, he should stop the engine idling to prevent the damages to engine, or he would be held responsible for gross negligence. Generally, such damages are not payable, but any special circumstances like driver fled away, injured, left the spot after the accident should be examined, explained convincingly, and discussed with the insurers for admissibility. Another case. The vehicle is driven in normal course with delayed detection of damages to the sump caused by some external object on a road full of potholes. And finally, the engine seizes due to oil starvation. Is the claim payable or not? Damage to sump is by accidental external means and payable, but engine seizure is due to gross negligence on the part of the driver. His failure to see red indicator light for oil loss. The claim is not payable. If the driver continues driving after knowing the damages to the sump, aggravates the loss, the gross negligence is not covered by the policy. If any compulsion to continue driving, please mind it, any compulsion to continue driving, despite knowing the damages to the engine, to avoid bigger loss is proved convincingly, insurers may consider the claim, but it should be discussed. Another study. A vehicle was proceeding from Srinagar to Delhi. After covering 5 kilometers down the hill, heavy rains started causing stones from hillside slide over narrow road. Suddenly, a loud noise came from the engine's bottom, and the driver slowed down the vehicle, but did not apply sudden brakes to avoid skidding or falling into a deep ditch, and also fearing a big landslide. The vehicle covered about 350 meters before it came to fully under control, driver control, and finally stopped. At the workshop, it was found that the oil leaked due to hole in the sump caused by hailstone, and engine ceased. As the driver drove further after the loud noise, under adverse circumstances. With oil leaked sump, can he be blamed for aggravation of loss due to chain of events in quick succession and with situation beyond his control or attempt to avoid bigger loss? Is the claim payable or not? Will you call it driver's gross negligence under such situation? If convincingly explained and discussed with the insurers, the claim is payable as per my experience in one of such cases. Let us study the picture below. Here is the hole in the sump. Here is the seized engine with the pistons cuffing mass there, and this is a big. This is the main bearing cap. This is the big end bearing cap, and you see the red mass here of that of overheating. Another example: a vehicle was proceeding on a highway. Suddenly, a loud noise came from the engine, and the driver slowed down the vehicle, and it finally stopped after covering some distance. At the workshop, it was found that there was hole in the engine block and the sump. After sudden opening of connecting rod cap nut, dangling connecting rod damaged the engine block and high-speed nut damaged the sump. This led to oil drainage and engine seizure. Should we blame the driver for aggravation of loss due to chain of events in quick succession and the situation out of his control? Is the claim payable? Because the proximate cause of accident being mechanical failure, and also there is no accidental external means factor, the claim is not payable. Let us study the picture of the damaged parts as below. You see the engine block is broken, and use the connecting rod is bent. This cap, big end cap is open. This is how. Type of damages to sump. How will you distinguish between a hole in the sump caused by connecting rod cap nut striking with great force or a pothole stone on the road damaging the sump and making a hole? As a surveyor, we are to reject the claim if the sump is damaged by cap nut inner part, or in second situation, accept the claim if the sump is damaged by an external object. The type of damages to sump will be different in two cases, and extent of damages need proper explanation. Study the following pictures showing two types of damages to the sump. In first case, some metal is projecting out. The second case, the some metal is pressed inwards. You see here two types of damages. Internal impact damages. You see that from here is the bulge on both sides of the sump. That shows the impact came from the inner side. Here you see the sump is pressed inwards. The impact from outer side will show the sump metal pressed inwards. The type of damages will show from where the impact was received by the sump, and that will decide the factor. Cause of engine damage is cooling water starvation. Cooling water starvation, what does it mean? In IC engines, combustion of air and fuel takes place inside the cylinder, and hot gases are generated in the combustion chamber at temperature around 2300 to 2500 degrees centigrade. This high temperature may result into burning of oil film between the moving parts and may result into seizure. So this temperature of cylinder inner surface must be reduced to about 150 to 200 degrees Celsius for the engine to work efficiently by cooling water circulation and stop water starvation. Too much cooling reduces the thermal efficiency. Cooling water starvation cases. A vehicle engine can suffer water starvation losses leading to seizure of engine. Let us study the cases. One case, a vehicle is driven in normal course with leaking radiator, water hoses, water pump, or insufficient water in the radiator, or leaking head gasket, cooling water mixing with oil and causing engine seizure. Is the claim payable or not? As the damages are due to mechanical failure and not by the accidental external means, the claim is not payable. Please note that the time taken for engine to seize again depends on vehicle speed, air drag, road surface condition, gradient, ambient temperature, cooling water quality, quantity, and the leakage rate. Another case, after the accident, the vehicle is driven without repairing or replacing the damaged radiator water hoses water pump. No spot repairs done before driving the vehicle from the spot of accident to workshop, causing engine seizure due to overheating or water starvation as cooling water leak. Is the claim payable or not? The damages are not payable because it is the case of aggravation of loss due to gross negligence. The insured should have towed the vehicle or stopped the water leakage at the spot. External water damages. Here you see the water wading of a jeep and another vehicle where the water can enter into the engine. Here the engine is submerged in water. External water damages. External water damages to vehicle engine are covered under Section 1 of Motor Policy for perils like flood, inundation, accidental external means. The damages may occur under following conditions. Parked vehicle submerged in water, fully or partly. Vehicle washed away by flood water. Vehicle falling into water. The type of damages to engine will vary as per composition, quality and type of water, duration and level of submersion. Please note, damages by water from river, sea, pond, lake, rain, flood, sewage to an engine are not the same. Water wading damages or hydrostatic lock damage will be discussed exclusively later. Parked vehicle fully partly submerged. Case study. The vehicle is parked in the basement of a building or on the road. Slowly the water level rises. The car is fully or partly submerged in water. The water may or may not enter the combustion chamber. Thorough cleaning and oil flushing of engine may be carried out after removing spark plug in petrol or glow plug in diesel or removing cylinder head as per the requirements. Minimum damage to engine will take place if there is no attempt to start the engine. The claim is admissible as damages are by accidental external means and indentation. Moving vehicle falling into water. A vehicle moving at high speed suddenly falls into a pond, river or sea and is fully submerged in water. As engine may not come to stop quickly, there is possibility of hydrostatic lock followed by bending of connecting rod. Water may corrode the engine parts if there is delay in pulling the vehicle out from water. Is the claim payable or not? The damages to engine parts are admissible as proximate cause of accident, falling into river, as accidental external means factor. Minimum delay to bring car out of water is expected from the insured. Damages due to type of water. If you know that the car was water damaged, it pays to know what type of water it was in, how long it was inside the water, and what was the water level. This can make a big difference. Study following examples. If the car was completely submerged in salt water for a long time, it is almost certainly going to be written off by the insurance company, unless it has been almost completely rebuilt. Salt water of sea or lake is very corrosive and will eventually weaken and destroy not only the frame, engine, body, but also the electronics of the vehicle. If the car has been soaked in normal water of river, rain, lake, it is possible to repair it reasonably after timely recovery of the vehicle. Now comes the hydrostatic lock, shortly called HYDROLOCK. Here we must understand the air intake system of IC engine. Here is, you can see the ambient air from the air cleaner enters here into the throttle body, and this is the butterfly valve, and this is the inlet manifold. Why this intake system is important to understand? Because in case of hydrostatic lock, that where the air is entering, the water will enter from. So to cause hydrostatic lock. Now let us study the next one. This is another photograph of the naturally aspirated petrol engine. This is the Ritz car. Here is the air cleaner, and here water. Air is entering from here, but in case of hydrostatic lock, water will enter from here. Now the turbocharged diesel engine. See the turbocharger here, and this is the photographic view, and here I have shown the animated view. The ambient air enters air cleaner. From air cleaner, it goes into the turbocharger, and the compressor wheel is here. And this compressor wheel compresses. Compressed air flow starts from here, and it is cooled down into the intercooler, and here it is burnt, and then the exhaust gases at high pressure travel and strike the turbine wheel here. Here is a turbine wheel. Now it gets its power from this high pressure gases, which move it, rotate it, and then they get discharged from the center. Here I have shown the ambient air entering here, the compressed air coming out, and the hot gases exit from the other side of the turbocharger. You see the supercharged diesel engine. Try to distinguish between the supercharger and the turbocharger. This is the construction of the supercharger is different. These are the two rotating wheels. Here, again, the ambient air enters the air cleaner, then it enters the supercharger, which is driven by the engine pulley. Mind it is driven by the engine pulley. And then the compressed air flows to the intercooler where it is cooled down, then it enters the combustion chamber where it is burnt out with the air fuel mixture, and then the exhaust gases discharge takes from here. Superchargers are mechanically driven by the engine. Belts, chains, shafts, and gears are the common methods of powering a supercharger, thus placing a mechanical load on the engine. It gets its power from the actual rotation of engine. But turbochargers get power from the pressure of exhaust fumes. The superchargers are fitted in the racing cars and as well as big commercial vehicles. Cut view of IC engine. This is the cut view of the IC engine. Here, the two intake stroke and the compression stroke are very important to understand the hydrostatic lock. Intake suction stroke. This is the intake, the one. Air is sucked from here. With the intake valve open and exhaust valve closed. This is closed and this is open. The fuel air mixture is sucked into the combustion chamber. This is the combustion chamber. But in HYDROLOCK case, water is sucked through this. Water is sucked through intake pipe in place of fresh air. Here is the compression stroke, where you see the both valves, exhaust and the inlet are closed here, and with both valves closed, the fuel air mixture is compressed. Here the fuel air mixture is compressed by the movement of this crankshaft and the upward movement of the piston. But in HYDROLOCK case, incompressible liquid. In HYDROLOCK case, instead of fuel air mixture, there is incompressible liquid, maybe oil, maybe water. Stops the crankshaft rotation and causes damages. Here you must understand the clearance volume, which plays a very important part in the hydrostatic lock position. Maximum volume you see here, orange color. Then in the red color you see the clearance volume, that is in red color. This is the top dead center, TDC of the piston, and this is the bottom dead center, BDC of the piston. It is the minimum volume formed in the combustion chamber when the piston is at TDC. Any quantity of water oil entry into cylinder greater than this volume will cause hydrostatic lock, and less than the clearance volume will cause no damages. Mind it, any entry of water or oil more than the clearance volume is going to cause damages to the engine. Now I give you one video showing how the hydrostatic lock occurs. You see, the air is entering and the water is also entering. Here, air coolant is there, and then in the compression stroke, what will happen? It will be closed, and the air piston moves here. The pressure builds up, and the hydrostatic lock takes place here. Then this will cause damages. Is the pressure that will burst and cause damages. I will show the damages here. You see here the damages: bent connecting rod, bent crankshaft, cracked block, broken piston, cracked head. Such type of damages take place. Now let us move to the next slide, and hydrostatic lock. You have seen how the hydrostatic lock happens. The water lock or oil lock. When external water instead of fresh air is sucked by internal combustion engine, petrol or diesel, during intake stroke, a specific quantity of incompressible liquid is locked inside the combustion chamber during compression stroke, and the piston will no longer be able to move up. This is called the HYDROLOCK point. When engine oil leaks into combustion chamber via leaked valve stem seal or locked cylinder head gasket, or water oil mixture takes into cylinder and settles above the piston head of an IC engine, a specific quantity of incompressible liquid is locked inside the combustion chamber during compression stroke, and the piston will no longer be able to move up. This is called the HYDROLOCK point due to mechanical failure. Here it was water, and here it is oil hydrolock. This is water hydrolock. So there are two different cases. Now let us study another case. After the accident, vehicle overturns or settles in upside down position. It stays in the same position till it is lifted late by crane. In such a situation, sump oil slowly leaks into combustion chamber due to enhanced piston bore clearance of the cool down engine parts. When the engine parts will cool down, the piston bore clearance will increase, and that will allow the oil to go above the piston head and settles above the piston head. When the vehicle is put back on the wheels, the engine oil trapped above the piston head can cause hydrolock to push the vehicle. After putting it back on the wheels will damage engine parts, bending, breaking of connecting rod leading to engine block damage. It is a gross negligence to be avoided. Either remove the trapped oil at the spot or tow the vehicle to the workshop to be on the safe side. Please note certain points here. The fuel air mixture is compressible in combustion chamber as against incompressible liquid, that is water or oil. Second thing to be noted, in a moving vehicle, if liquid volume above a piston head is less than clearance volume, no hydrostatic lock will occur. Engine would miss momentarily and regain RPM. Note 3. In a moving vehicle, if liquid volume above a piston head is more than clearance volume and hydrolock piston is forced to move up, by torque developed by combustion in other cylinders along with momentum of heavy crankshaft, flywheel, reverse thrust from the vehicle wheels caused by vehicle momentum. It would damage the engine parts. Connecting rod, being the weakest link, would bend first and break afterwards. Then piston, crankshaft, and engine block last damages. A piston is designed to withstand fixed amount of thrust developed in the combustion chamber, and excess of thrust would damage it. Can a self-starter damage hydrolock engine? As the torque generated solely by self-starter is much lower than engine's operating torque, it is not capable of rotating a hydrolock engine, hence causing no damages to the engine parts. But there is another different case. The water wading vehicle suddenly stops in waterlogged area, or a parked vehicle is submerged in water, but its engine might not be hydrolocked, as external water entry into the cylinder is nil, or its volume is less than the clearance volume. The self-starter can trigger ignition and start the engine, but it will stop shortly due to sucking water present in the air's intake system parts and hydrolocking the cylinder in compression stroke. Thus, the engine parts can be damaged. Hence, aggravation of damages due to self-starting a water-submerged engine when it is inside the water or out of water are not fair. Hydrolock engine damages. You see the water on the piston head in all these three cylinders. Here the connecting rod is bent. Here this is broken connecting rod and this is a broken piston. Water is sucked into multiple cylinders till it exceeds clearance volume in a cylinder. It will keep on entering. Now driving vehicle into flooded area. A vehicle is driven through waterlogged underpass on a way and suddenly engine stops due to waterlock caused by sucking water from the air intake system. If there is an attempt to restart vehicle by pushing, it would result into serious damage to the engine parts like bending of connecting rod, piston damages. Damages to engine parts are not admissible due to driver's gross negligence for push starting the engine under such circumstances. In such a situation, vehicle should be towed to workshop. Systematic fixing would minimize damages and would be acceptable. Fixing a water submerged engine. How we should fix up a water submerged engine? There should be a proper plan for it. First, you study the following points to decide the action plan. Water line means the water level up to which the car was submerged or the vehicle was submerged. Then the water type, what type of water, the water duration, how much it was in water, and water quantity entered into the engine. Check water presence in following parts. In sump by dipstick, you remove the dipstick, check up for any water there, mark there. In air cleaner by opening. In cylinder by cranking the engine after removing spark plugs in petrol engine or glow plug injectors in diesel engine. What should be the action plan? If no or small quantity of water is in cylinder, oil flush the engine. If the engine resists cranking or loss of cylinder compression is noted, open cylinder head to check the liners, cylinder valve for rusting, and open sump piston to check connecting rod bend. Therefore, engine overhauling is recommended for correction. If the car is soaked in salt water for long, it is a total loss. Please note that in major cases, full or half engine is replaced, and earlier the fixing, lesser the damages to the engine. Marking flood water level. Here, one of the buses, luxury buses I was surveying, and the water was up to this level. So I made a line here, water line, called water line. Now All the parts below these lines were considered in my claim, and all the parts above this waterline were rejected by me. Engine protection cover as add-on. This add-on in car insurance policy shields against all engine gearbox parts damages by accidental leakage of engine oil, gearbox oil, water ingress during water wading of the vehicle, hydrostatic lock. When you repeatedly try to start a moist or submerged engine, it covers engine parts failure. Please note, cranking the engine during or after the car is submerged underwater can trigger ignition and damage the engine. This gross negligence is not covered under the base policy, but the add-on policy can cover it as per conditions specified. It excludes damages due to mechanical failure, that means leaked parts, leak radiator, leak head gasket, all this. Cause of engine damage is accidental impact. Accidental impact. Engine may be damaged after receiving high intensity impact from external source, internal source, both internal and external source. Let us study the following cases. Impact from external source. The vehicle engine sustains high intensity impact at front, top, bottom, back side, left side, or right side from another moving vehicle in case of head-on collision or by an outside external object. As the damages to engine parts are by accidental external means, the claim is payable. Impact from internal source. An engine sustains impact from internal moving parts like broken or dangling piece of connecting rod or broken piston skirt causing severe damages to engine block, sump or crankshaft called mechanical failure. In the absence of accidental external means factor, the mechanical failure claim is not admissible. Impact from both external and internal source. After the impact from the external source, the timing belt of engine is broken, thus disturbing the valve timing and valve movement. This results in particular piston dashing against the open valves, causing severe damages to the internal parts of the engine. Common in case of older Tata Sumo vehicle having longitudinally placed engine with timing belt and overhead valves. Since proximate cause of accident, impact from the external source, because when there is a collision there, as accidental external means factor, the damages to the internal parts of the engine are payable. Impact from both types of sources. A truck loaded with iron rods dashes head-on against another truck from the opposite direction. There is high intensity impact on the engine pulley at front side. Due to the high momentum, heavy iron rods shift forward, break the driver cabin wall. You see the composite cabins were weak and could be broken by the iron rods, heavy iron rods. Dash against the engine hood and finally damage the tappet cover and cylinder head. Are the damages to cylinder head admissible? Since proximate cause of accident has an accidental external means factor, the damages to all engine parts are payable. Please note, damage to vehicle part by forward shifting of iron rods is not payable if the proximate cause is hard braking, not an insured parent. If due to hard braking, this iron rods shift forward and do the damages, they are not covered because the proximate cause is not an insured parent. Cause of engine damage due to fire, external or internal source. These are the fire damages and this is the condition after the fire. Fire damages. Fire from outside source or internal source like self ignition, short circuiting affects Various parts of engine and different stages of fire damages are explained below. Softening. Parts made of rubber, nylon, fiber, plastic materials are first to soften hoses wire like hoses wire engine mountings. Overheating. Metal parts get overheated and the color of the metal shows the amount of heat received as per table in the next type. Melting. Softer metals like aluminum alloy or lead are first to melt on receiving excessive heat, and iron parts will melt later. Burning to ashes. Melted parts and rubber parts may burn to ashes on receiving much higher heat. Please note that claim for the parts rendered unserviceable due to softening, overheating, melting, and burning to ashes are admissible as damages due to fire are covered under the policy. Also note, but the insured must ensure that he made best efforts to contain or control the fire damages to his vehicle, inform the fire brigade and police, and that there is no gross negligence on his part. It is important to study the melting boiling points of metals and their color changes with temperature as shown in the next slide. Color chart for heated steel. Steel is an alloy of iron with less than 2% carbon. Here on this side you see the temperature rising from 220 to 15. On the right side you see how the color of the steel changes. At 220 shining light yellow color, then at 400 brown to purple, at 500 reddish to grayish, at 600 dark red, at 700 red, 850 light red, 900 yellowish red, 1000 yellow, 1100 light yellow, at 1200 white, and shining white at 1250 till it melts at 1500 degrees centigrade. From here the color you can see how much heat a particular steel part has received. Mechanical failure. Mechanical is the definition is mechanical failure or breakdown of an engine part is said to have taken place if it undergoes premature failure without completing its optimum life period while in operation due to excessive fatigue, stresses, overheating caused by oil water starvation, any gasket leakage, bad maintenance, manufacturing defect, using superior spare parts, defective fitting, and defective machine shop work, that is reducing fillet radius while grinding crankshaft journals. Please note the insurance company is not liable to make any payment in respect of mechanical failures or breakage of engine parts under normal use of the vehicle. For example, a loaded truck was proceeding on road and suddenly the driver hears a loud noise from the engine. He gets nervous, swerves to left extreme, but finally the truck overturns into a roadside. The repairers submit the estimate for body damages and also engine damages as the crankshaft was found broken after the accident. Now question, OD claim for body and engine is payable or not? Answer, body yes, engine no. Engine damage is due to mechanical failure as crankshaft can't break due to vehicle overturning. But body damages are by accidental external means after the vehicle overturned, therefore payable. Question 2. Why and how crankshaft was broken? If the fillet radius is cut to shorter size during crankshaft regrinding due to critical stresses at the change of cross section, here crack will be developed and end in the breakage of the crankshaft. You see the study the crankshaft regrinding rules. Here you see the crankshaft. I have shown you these are the main journal. This is first web. This is big end journal or also called crank pin. This second web. second journal, third web, again crank pin, fourth web, and the third journal, main journal. Here is the dimension. One is as specified the manufacturers, that how much dimension you are to keep. So the table above shows crankshaft dimensions after machining, the fillet radius of 4 mm as marked by circle. They have said that D should be here, D should be 4 mm. Must be maintained while regrinding the main journal, big end journals of crankshaft during overhauling. But fillet radius smaller than the manufacturer, this fillet radius smaller than the manufacturer specification would generate critical stresses at the change of section. This is the change of, this is one section, this is another section. So there is a change of section here. So critical stresses will develop here at the change of cross section. Critical stresses at the change of section where a crack will start. This is a mechanical flow. A crack will start. Engine will be moving with a small hair crack, but already mechanical failure has taken place and end up in breakage of crankshaft under high jerk. Under the jerk of accident, this will break. But this is not payable because already mechanical failure had taken place. Thank you, my dear friends. Please send your question, comments to mail ID training@isla.net. Thank you, sir.
Thank you, Walia sir, for such a wonderful and insightful session. It is a very basic but very essential knowledge required for the motor surveyors, and majority disputes are created because of these fundamentals is not clear with the surveyors. I hope that surveyor will utilize this knowledge and avoid disputes. Now we will take a few questions. If anybody is there.
No, sir, there is no question written on question box, sir.
Okay, fine. So, members, I request that if you have any questions, any queries, you can send us a training@isla.net, and definitely we will conduct a second part of this session also, because fundamentally it is very necessary, this kind of session for the motor surveyors. So keep writing us on this topic at training@isla.net. We will call Walia sir to again clarify your doubts on this. Thank you, Walia sir. Thank you all the members.
Thank you, sir. Thank you very much.
Thank you, everyone.